Hello everyone, my name is Maria Christina Miem. I'm the LightCon project director at Deutsche Messe, and I would like to welcome you to our preview week. I know that we have some participants from all around the globe, so good morning, good afternoon, good evening, wherever you are right now. Well, tomorrow on 23rd June, we would have celebrated the premiere of LightCon, the first international congress trade fair for lightweight solutions and across materials, across technologies, and for all user industries. Due to the Corona crisis, we had to postpone the premiere to next year in June. So of course we were all really sad. But I'm all the happier that we can still meet virtually and that so many people have registered for our webinar week. So far we have more than 300 registrations. That is great. And for today's first webinar with Yves Mattern, we have 180 registrations. As far as I can see, we have more than 50 participants right now. So hopefully some more will join us. But already right now, this is awesome. Big thank you to all of us for joining us. And of course to Yves Mattern, who will share some of his insights with us today. And last but not least, I would also like to thank our founding partner, Composites United, for the great cooperation and for the support in organizing this event. And what we will be presenting to you within this preview week is only a small foretaste of what LightCon 2021 will be all about. And not only in the Congress part, but also in the exhibition. So stay curious, and I hope you will enjoy today's webinar. So have fun, and now I would like to give over to Bastian Brenken.
Good morning, everyone. My name is Bastian Brenken. I'm the Technical Director of Composites United. And it's my pleasure to welcome you as well today for our first webinar in the first webinar series of the LightCon. I will explain to you now the structure of this webinar and also some technical details about Zoom if you're not familiar with the Zoom yet. So the LightCon, today's webinar is structured in two parts. The first part, about 30 minutes, Mr. Mattern will present his talk. During that time, all microphones and all cameras except for his will be turned off. And in the second part, the second 30 minutes, you will then have the opportunity to ask your question, make a remark, or start a discussion. And for that, we will use the raise your hand function in Zoom, which I will explain then. You will see, what you're seeing right now is the shared first slide of Mr. Mattern's presentation and some images, some small images. If you want to minimize that, move with your mouse to the small screens and click the thick button, the thick bar, which is the second button from the left on the top, and then you will only see the active speaker. And this is the recommended setting that you should choose to not block too much content of the presentation. With that, I hand over the word to Mr. Mattern. Yves Mattern is Managing Director of Lignoa Leichtbau GmbH, and he will talk today about the exciting material wood as high-tech material of the future. Mr. Mattern, the stage is yours.
Hello, everybody. Thank you very much for being here. I'm very glad that I can be part of this virtual congress. I will give you a short brief overview to my person. So I'm not a wood engineer, or I'm not a joiner or something like that. I am carbon engineer. I studied in Dresden. And over there, from the university, I knew my partner Philipp Strobel, and together we founded just 2 years ago the Lignoa Lightweight GmbH. So Leichtbau means lightweight for those people who are not German speaking. So and this is what it is about. Everything that we do is about wood. Wood as high-tech material. So, and most times with our developments and the products we develop, it is about lightweight, not just high-tech, it's lightweight most times. So what we do and how we work are those three pillars. So the first and most important step for us as company is development. So product development. We work as service provider, as development service provider, and we develop your products out of wood. So everything for us started with developing a wheelchair. During university, we wanted to develop a very light and a great designed wheelchair. And then we thought, oh, why is that not possible with wood? And we looked all over the world for technologies for producing free-formed wood tubes. So if you don't look to the presentation and look to my window, you see one of those tubes here. It is three-dimensional formed, and this process is that what I will explain most in this presentation. Because the technology is very new and there are not so much experiences with producing companies, we work as a subcontractor as well. This also means that in the end of development, we produce the products by ourselves, and if the series is too big, we got two partners who are licensed with our technologies for continuing producing the bigger series. And the third, and I call it the startup pillar, is the technology development. So we not just want to develop products. That's our passion a bit, yeah, and it's cool to have a wooden bicycle or a handlebar, but we try to develop new technologies that make it possible that almost every kind of product could be out of wood. So I'm not talking about engines or something like that, but structural parts. For example, I always say in 10 years, we could develop a chassis of a vehicle completely out of wood. Not the turning parts, just the structural parts and the chassis. So, like I already said, everything started here with that wheelchair that was part of my diploma. And I developed it together with Philipp Strobel over here. And then we got the question, is it possible to develop a stroller? And yeah, our aim is to develop very interdisciplinary and across all industries products out of wood. So now I just talked about us. I will talk about wood now, about wood as lightweight material. So, like I already said, I am carbon engineer. The most steps how we produce wooden products is very similar to carbon, especially the simulation or topology optimization that we do. So we are talking about a fiber-orientated material. Fiber-orientated material always means we hope that the load is exactly in the direction along the fiber, because like everybody knows, wood is very strong along the fiber and not so strong in the right angle. So if you look to my video again, I will show you a veneer. This is very important in the following slides. This is veneer. Veneer is something that you cut out of a tree very thin. So most times less than 2 millimeters. This one, for example, is 0.6 millimeters. And if you see this veneer, you can pull very strong in the direction of the fiber and in the right angle to the fiber. It's very easy to crack. But because it's so thin, you can bend it. You can bend it very, very strong. So, and this is the point why we use veneer, because of the bending, we can orientate the fiber. This is one of the most important point for working with wood as lightweight material, not to have solid bars. So if we have a fiber-orientated material and talk about lightweight, I learned in Dresden at my university where I studied, the most important thing is not the technical properties, it's the specific technical properties. Yeah, I know the technical property, the tensile strength of wood in fiber orientation is much worse than titanium or carbon fibers, but we have a density of 0.4 up to 0.8, depends on which wood we use. So, and that means we can use more material having the same weight, and then we have the same product properties. This means that we need enough space. Lightweight always means using the right material at the right place. So if we talk about products that are very thin and very small, yeah, wood is not the right material for that in most cases. It depends on how the load is included in the product, but yeah. So we are always talking about products where we have a bit more space than the actual profile, yeah, the actual CFK or aluminum profile. So if you look at the Ashby diagram on the right side, you see at the x-axis the specific Young's modulus, and on the y-axis the specific tensile strength. So it is the Young's modulus and the strength in relation to the density. And in this case, you see that the Young's modulus is as high as titanium or different aluminum alloys or steel. Yeah, so it is in German. I think the most people here are German. I don't know, but yeah, here you see this one means steel, and the specific tensile strength is even higher. So here you got some fiber materials. They are, depending on what you look at, a bit better or a bit worse. But this diagram shows how strong is wood as lightweight material. And now we just talked about the material and the properties, but there are indirect advantages you see here. Indirect advantages are very important for lightweight construction because the good vibration damping of wood means we don't need additional elements for damping the vibration. That means lighter. Just the structural element already is a good looking part, a modern design part. So we don't need another surface or something like that because it's already beautiful. Wood is beautiful. I think everybody is the same opinion. I can't hear your opinion, so that's good for me. And another very important point is the low thermal conductivity. So the products we developed up to now, it's about tree pots for cameras, it's about parts in the automotive sector, it's about drones, it's about bicycles, strollers, and for all of them, the low thermal conductivity was very important because if you touch it outside in winter and you don't have gloves, it's very much it feels much better if the material feels warm. So the Wund 3D tubing, that's the name of the process that I showed you, this tube. This is exactly the tube that you get here on the picture. And why is it so important for having a three-dimensional formed wood profile? Because of the points that I said before, the fiber orientation and which is along the load direction. So we got, because of that, of the fiber orientation, we got very good lightweight properties, up to 30% lighter than a comparable aluminum profile. Comparable means with the same specifications, with the same properties, if you talk about properties and product. So we got a very good freedom of design, which was not possible before with wood, having complex formed profiles. And the points here, they are just interesting for our investors that we are acquiring. But high sustainability, I will just shortly talk about that, because I think I don't have to explain that wood is very sustainable and very ecological. We got a lot of trees in Germany, in Europe. We can use much more wood without hurting the forests. We got CO2 inside of the material. And that's all I want to talk about that. If somebody is interested about the sustainability of wood, you can find like 500, like millions of slides about that in Google. I'm an engineer and not a sustainable man. So, how do we develop a profile, a V3T profile? Like I already said, it's all about the orientation of the fiber along the load. We got, I will explain it later how we produce it on the next slide. So, but here you see we got the fiber orientation exactly along the profile axis. The most loads, if you have a hollow profile, are in direction of the profile axis. Here, this part is one shell of a tube. I call it tube now. One shell of this tube. One tube consists of two shells. This means that we get this profile, we get it hollow by milling it out. If we mill it out, we can mill out whatever we want. And this is why we do topology optimization, because we get different loads, different strength we needed in the product. So we do topology optimization and having the wall thickness variable depending on the load that we have. After the topology optimization, we do a simulation. And after that, the machining helps it to be exactly the product we want to have. Here are the 6 steps for producing a profile like that. So I switch my explanations between the presentation and my video. So if somebody do not have the video switched on, my video switched on, it should be an advantage. So this profile is banded like that on the first form. If you remember the veneer, it's bendable. If we have 40 layers of this bendable veneer and glue it together over the form, we got a very solid body consisting of 40 layers. This body we will cut into new layers. And the second step we do just for having fiber-orientated veneer. So if you see the red lines, this is one surface, this is one plane that we want to cut out of the solid body for having a fiber-orientated veneer. This is the only sense of the second step. If we don't need a 3-dimensional formed profile, for example, just a 2-dimensional formed like the shell you see on the left side, then this step is not necessary. The third step is the same step as the first one. The cutted veneers, the fiber-oriented veneers, are bended over a form to have exactly the 3-dimensional fiber orientation. And after that, we mill the structure like I told in the slide before, producing 2 shells and glue them together. This is the point where most people say, "Oh, that's so costly. 6 steps for producing just 1 tube." Yeah, that's right. 6 steps in our house. And before there is 1 tree, and the tree is slided into veneers. So 8 steps from the tree to the product. And this is the real sustainable and the real comfort point with this process. 8 steps from tree to product. Try this with metal from mine to product. So without having the stone and everything. And so it is not too costly as everybody thinks, because all of this steps is doable with standard presses and standard mills, CNC mills, and very easy ones. So it is in a bigger series, it is not too hard to process. What means the result of a profile like that? It means if you compare it with a profile of aluminium alloy, a T6 aluminium alloy, then we have, when we look at a profile with the same weight, we have 10% more stiffness and 50% higher strength, and that's a lot. 2 times higher fatigue strength. So this means to be lighter as aluminium never is a problem with our profiles. Carbon, yeah, that's a target that we have. I think we need 1 or 2 more years to process the process up to that point. But in some cases, we are even lighter than carbon. For example, if carbon is too strong, but we have the minimum wall thickness that is possible to produce with carbon, it's almost the same minimum thickness, wall thickness with wood, but because of the low density, we are lighter. But this is another point that is hard to explain without being on a stage. So this is how it is possible to simulate wood. Most people are a bit afraid of simulating wood. I understand this. There are holes inside, it's not homogeneous, and all of this. But if you use 40 layers of wood and glue them together, cut them into new fiber-orientated veneers and glue them again together, the first 4 steps, I will go back, the first 3 steps of the process, then you get a very high homogenization, and because of that, it's not very hard to simulate. I am not a simulation crack, and it is not, we got like 5% in the maximum from the simulation to the product difference. Yeah. So how you see here in the elastic part, so in the part of the Young's modulus, we got a perfect simulation for the testing bodies. The yellow line you see here, that was a pre-weaked body where we put a hole inside to see how hard it is, how much more easy it breaks. Yeah. The other ones are normal ones, and the orange line is the calculated strength. So you see, it is good calculable, and it's not only with that body. That body was a very complex inner structure. I don't have a photo now of that, but yeah, we have a lot of success with that. This slide is just for the engineers who want to check some simulations or something like that. So it is not too important now at the presentation, but because the presentation will be in YouTube, I think, if you want to look for the properties, you can find them here. But what is to say with that? You can see here laminated beechwood with epoxy. With this process and another process that I will just shortly explain, we are independent of the wood type. We can use a lot of different wood types and a lot of different glues. The glue we use depends on the weather that we have outside, if we're developing something for outside, or yeah, it depends on what the product has to work with situations. Yeah, I think you all know what I mean. So it is also possible without a problem to use other glues, to use other wood types. Beechwood is very good, like we saw before in the Ashby diagram. But you also can use birch or oak. It depends on what we have cheaply in Germany now that we can buy as veneer. So this is just one example. We got better lightweight woods and we got worse lightweight woods, but beechwood is a very cheap one that is very good. So it's a good relation. I will shortly say something about the indirect advantages, like the damping behavior. Here you see the damping behavior. So from the amplitude to 0, and this one is aluminium, this one is steel, and this one is wood. So we got a 4 times higher damping behavior than aluminium. So if you have a light aluminium product and have additional damping element, this could be that this one is not necessary if you take a wooden profile. This is an example that we produced for showing what the process is able to produce. So the inner structure of this hollow body is topology optimized. We don't have here, but it is possible to integrate some inserts like lamps or like brakes or something like that. Because we mill the inner structure, we can directly prepare enough space for the integration of some other function elements. The good damping is very good for this fixie here because we got no damping fork or something like that. And if it's cold outside, it's about the warm feeling. And because of the design freedom, it is very easy to integrate ergonomical geometry. Yeah, so this was about the Wund 3D tubing. I hope that there are some questions about that. I will just shortly present another process for constructing lightweight structures out of wood. And this is about this tube. I don't know if you see it in my video, it's hollow. It has the same thickness all over the profile, but the profile is not circular. We can variate this profile, and this is why it's called free profile tubing. The tubes that we produce with free profile tubing are the lightest wooden tubes in the world. There is no other wooden tube that is as light as this one. We can define the layers. So we got 4 layers in the wall thickness, and we can define completely the fiber orientation. And this one we use, for example, for the 3-pot for cameras and something like that. We are developing a pultrusion process for producing those kind of tubes, for having a very low-priced alternative to aluminum tubes, steel tubes, or polymer tubes. Yeah. Here you can see one example where we use this in our office, but like I already said, a tripod or a pedal that we developed, there it is usable. So I think everywhere where you need straight tubes, yeah, this one should be the process for wooden straight tubes. This is what I wanted to show you in the end of my presentation. The interdisciplinary of our processes of wood as lightweight material should be independent of the area. So we are not a subcontractor for automotive. We could be, but we want this just being a part of that. We want to work across all industries. It doesn't matter if it is a tube for cable or furnishing or medical devices or lifestyle products. We are developing those technologies, and yeah, if this technology doesn't exist up to now, perhaps we will develop it the next years. So thank you very much. This is how we are be in contact with you. This is my partner Philipp Strobel, this is me. And just write an email if you have any question about wood. I think, I don't know if there's anybody in Germany who knows so much about wood as lightweight material as we do. So thank you very much. And